In this video, we're going to look at the mathematical concept of relations. First, we're going to define what a relation is, and then we're going to look at 6 different ways of representing relations. So a relation is simply a rule that matches values of an input variable, which we often call an x variable or an independent variable, with corresponding values of an output variable, a dependent variable or a y variable. So to give you an example, let's say that we had this shape over here, this ellipse in red, containing all these different potential values of a superhero variable. A superhero could be Superman, could be Batman, could be Spider-Man. We're going to call that the input variable. And over here, we've got a different set of values. These are going to be our output values, and they're secret identities of potential superheroes. So Clark Kent is the secret identity of a superhero, so is Peter Parker, so is Bruce Wayne. Now, a relation is just a matching rule between these two different sets. It takes the input set and the output set, and it matches them together. So that could be something like this. Superman gets matched with his super identity Clark Kent, Batman gets matched with Bruce Wayne, Spider-Man gets matched with Peter Parker. And by drawing these arrows and matching the input or the red x variables with the output or the blue y variables, we get what's called a relation. And again, a relation is just a matching rule between one set of possibilities, or one set of variables, or one set of values, and an output set. And this kind of diagram with these ellipses like this and arrows between them is called a mapping diagram, and it's a common way of representing relations. So to get more mathematical, we could have a mapping diagram that looks like this. This is a relation that takes 1 and matches it to an output of 0. If you put in 4 into this relation, you get an output of 0. If you put an input of -5 in, you get an output of 3. Input of 5 gives you an output of 9. Input of 6 gives you an output of 4. So again, it's a matching between an input and an output. So there are several different ways of representing relations. One is to just talk about it in words. We could say that the output variable y is the secret identity of the input variable of x if we were using the superhero values from before. We could draw a mapping diagram like we've seen with the two different ellipses, where we have one set for the input and one set for the output. Additionally, we could make a table of values, and typically we put the input values on the left and call them x, and the output values on the right and call them y. So if you look back to the last mapping diagram, and now you compare that to this table of values, you'll see it's representing exactly the same information, just in a different format. Again, we have the x's on the left and the y's on the right, inputs and outputs. It's also common in math to represent inputs and outputs as a set of ordered pairs. So again, x is first, y is second, x is the input, y is the output. So we could take this table of values, which was the same as the mapping diagram, and draw it, or write it out rather this way. -1, 1 means an input of -1 gives you an output of 1. 636 means an input of 6 gives you an output of 36. And 0, 0, input 0, output 0. We're used to also seeing relations expressed as equations. Y is equal to x squared. Again, y being the output, x being the input. This is telling us that whatever you put into this relation, you square it, and the output you'll get is going to be called y. So input 6, square 6, you get 36 as an output. And one final way of representing relations is in a graph. In a graph, the inputs are represented in the horizontal dimension and the outputs in the vertical dimension. The x coordinates are the input, the y coordinates are the output. So if you put in 1, you move along 1 in the x dimension. To find the output, you trace up to the graph, and you get a y value of 1 as well. So an input of 1 gives you an output of 1. Input 2 means move along 2. To find the graph, you have to move up to 4. That means an input of 2 gives you an output of 4, representing the same information as before. Okay, so 6 different ways of representing relations.